Hello, everyone. Thanks for your time today. My name is Samal, and I'm the Director of Marketing at Scaled Inference. I'm your host today and welcome you to our first in-house webinar at Scaled Inference. At Scale Inference, our mission is to make AI accessible to all, and we help growth experts improve their KPIs through continuous optimization. Now, I would like to introduce you to our speaker, CEO, and founder of Scale Inference, Oljan Sersinoglu, who has over 25 years of software developer experience. And he has been associated with artificial intelligence, machine learning, and reinforcement learning for more than 15 years now. Before founding Scaled Inference, Oljan was an engineer in Google Brain, where he led several core platform projects that now power virtually all major Google services, including web search and Google Trends. During this webinar, he will be sharing his insights and use cases on personalization via reinforcement learning. Feel free to ask questions using the chat button on Zoom at your screen, or reply to my thank you email post-webinar with any questions you may have, and I'll be sure to get your answers. Also, we'll be recording this video so we could share with you and others who couldn't join us today. So without further ado, I'll hand it over to Oljan to kick off this webinar on personalization via reinforcement learning. Oljan?
Thanks, Somel. Hi, everyone. Welcome. This is Oljan. And this is actually only our second webinar and definitely the first one on this topic of personalization, and also with a different perspective of reinforcement learning. Usually we call this autonomous optimization, so this should be interesting in that regard. As Samuel mentioned, I've been building software for over 25 years now. I was at Google Search, Research, X, and Brain when I was last there about 5 years ago. And AMP.AI, sorry, let me just screen here. AMP.AI, which you see the bot head on the lower left, is our personalization and optimization platform where we use reinforcement learning behind the scenes. So that's why we wanted to do a webinar specifically on this topic. Now, the agenda for today is quite simple. We'll start by talking about personalization, and we'll talk about how it relates to optimization, which is the other way that we describe what we do. Next, we're going to look at reinforcement learning and special forms of reinforcement learning that are more ideal for personalization, especially. Next, we'll go over some real-world examples from many well-known companies, including some of our customers that use our platform, as I mentioned earlier. And finally, we're going to review some of the key benefits, especially in helping experts drive growth. And to do that, we're going to take a step back and kind of describe a process that we recommend companies follow for using this kind of technology instead of especially traditional A/B testing methods. Now, I just want to say before I start that we're going to be talking about two very big topics today. You know, personalization and reinforcement learning are both very deep topics in their own right. And they don't usually get presented in the same talk. So my goal today is to focus on presenting the key concepts as clearly and intuitively as I can. I will do my best to not confuse people with jargon, you know, regardless of your background. If you're familiar with reinforcement learning or machine learning, or if you're familiar with personalization, but not so much machine learning, I'm hoping everyone can get something out of this talk. Okay, let's get started here. So let me introduce personalization in a certain framework that's going to help me introduce also what we do and reinforcement learning as it relates to personalization. So simply put, personalization is the process of delivering for each customer the best variant of our product or service. Here, you can imagine that we have two variants of our website. You can imagine just the home page, if you like. The two variants are indicated in gray and blue. And when a customer views our website in their browser, let's say, we personalize the experience by deciding which variant is better for the customer. Now, first we have to define what we mean by better. And we do this by defining a desired outcome and the corresponding optimization metric, such as a conversion rate or an average order value, if this is in e-commerce especially. And once we defined our metric, personalization requires predicting which variant would be better for this person, given the metric and all available context. In other words, we need to predict if this is a gray person, a person who would do better given the metric with the gray variant, or a blue person, a person who would do better with the blue variant given the same metric, and then decide accordingly. Now, let me go over a more concrete example where we're looking at personalizing product pages to optimize for a specific metric, in this case, the average order value in a checkout flow. And to make the metric definition precise, here we introduce the notion of a session, which is simply a sequence of related events and attached properties. We're going to start looking at the session with a very special event that we call a decision event. And in this case, during the checkout process, we're deciding on the product page user experience, deciding on things like which thumbnail should be used, whether free shipping should be offered, whether the UI should emphasize going to checkout directly or adding other items to cart. So these decisions can be made at some point in the session. Now, by the way, at the bottom, we're listing the specific events and properties for this example. So you should take a look at that. And we read that from left to right. Now, the decision point is also special in that it splits the session into basically two halves. So all of the events that happen before the decision point are what we call context that can be used in making the decision. So for example, in this example at the bottom, the session might start with a built-in event that we call AMP session, where we would collect some of the built-in properties such as time, location, device, network, browser, and such. Typically, customers would introduce, depending on the use case, some custom context into the session with an additional event in which they could indicate things like whether the customer is a new customer or returning, whether they're free or premium, any past activity or purchases, and so on. Now, all of these events and properties that are observed prior to the decision point become context for making the decision. And any events that happen after the decision point are what we call outcome events that can potentially be used to define the metric that we want to optimize for. Now, I want to also mention here, let me go back one step. That at the decision point, one of the main things we're doing is deciding whether this context, the context that we have access to at the decision point, fits the segment on the left or the segment on the right, as you see up here. Let me highlight this up here. So if it fits the segment on the left, that segment is dominated by gray people. If we could magically look into it. So in that case, of course, the gray variant would be better. But if we think that this user falls in the other segment that's dominated by blue users, then the blue variant would be better. Now, let me talk about reinforcement learning and how that fits into this picture. What I have here on the screen is simply the illustration that you can also find on Wikipedia. And just as a very high-level introduction, reinforcement learning is one of the 3 types of machine learning that you can also read about on Wikipedia. I won't get into the other 2 as much, but they're called supervised and unsupervised machine learning. Reinforcement learning is actually more general than the other 2 types and can actually make use of the other types as needed. For example, to handle very large state spaces or action spaces. What makes reinforcement learning special and more suitable for personalization is that it seeks to build systems that learn to maximize a reward, a numeric reward specifically, which fits perfectly well with the framework that we just introduced, where we define a metric and we seek to optimize the metric. And let's actually map this to our framework, where we have the environment generating sessions and the agent observing the context that it needs to make a decision, and the outcome or the metric that corresponds to the last decision that it has made. So the agent simply receives context, make a decision, observes the outcome, and so on.
By the way, there was a question on the chat window, which was, what is AMP and AMP session? So Ojan, would you like to answer that question?
Yes, yeah, let me answer that. So AMP is referring to our platform, amp.ai.
Mm-hmm. Great.
Sorry, I'm rusty with Zoom here. This is the first time we're hosting our own webinar. So the reinforcement learning framework that I just introduced is fully general, but most personalization work is actually done under 2 special cases that are usually called multi-arm bandit and contextual bandit. Multi-arm bandit, which you see at the top here, let me highlight here, assumes no context. As you see, there's no context here, just an action and a reward. Or you could say it ignores context, which also means that there's no segments and no personalization. So in a sense, multi-arm bandits is like the optimization-focused cousin of A/B testing, in the sense that it's designed to maximize growth or maximize metric gains rather than manage risks such as type 1 errors. Contextual bandit, on the other hand, which you see below, is also a simplified version of reinforcement learning in that it assumes a single step. So both of these are actually single step or one-step reinforcement learning algorithms. But in contextual bandit, we do allow context, which means that we can actually learn segments and we can personalize our behavior. And so one way to describe this is that it's like multi-arm bandit combined with continuous automated segmentation, which not only improves the metrics, but it gives us personalization, of course, and segment insights, as we'll see later. Now, let me give you some examples from industry. I'm skipping Google here because I could not find a publication by Google describing a personalization use case. Of course, Google and DeepMind are famous for things like, the DQN paper for playing Atari games at superhuman levels, AlphaGo, AlphaZero for playing Go and chess and shogi at superhuman levels, for actually saving power on their data centers by a significant percentage. But none of those are really personalization use cases, so I'm not going to talk about those. And instead, I'll just focus on industrial applications of personalization, of reinforcement learning for personalization. So Amazon has published last year, I believe, about using contextual bandits to personalize the display of 48 possible variations of a promotional message for an Amazon service. And they reported in that paper that it resulted in 21% improvement in conversions after only 1 week. Now, Amazon likely uses contextual bandits for many other things, but they have not published about those yet. So we would be speculating. But it's probably safe to say that. Now, Facebook recently published about their applied reinforcement learning platform called Horizons. And they report in that paper that they have applied it to personalize push notifications, page admin notifications, and video compression and buffering algorithms. They also mention other projects, but they don't go into detail. Microsoft has definitely used contextual bandits to increase engagement on MSN network, and as well as in other products, we believe, based on some of the content they've released, although they have not discussed these in detail publicly and not in published papers to my knowledge. Yahoo was actually one of the first major companies to publish about using contextual bandits as early as 2010 here. You can see the date, I think, in this paper. And in this case, for personalized recommendation of news articles. You can see here the featured tab where they're selecting the story to be featured. Now, Uber has been public and very open about their in-house experimentation and optimization platform. And they report using it for quite a few use cases here. I'll just kind of focus on this slide up here, where they talk about using it for content optimization for their ad campaigns and landing pages, for spend optimization, including bidding and promo strategies, hyperparameter tuning of other types of machine learning that they use for Uber Eats ranking, and recommendations for Uber trips. And they also report using this for automated, safe, incremental rollout of new product features. Netflix is definitely a major user of contextual bandits for personalization, and they report personalizing many things. Actually, if you can see on this slide, they say they personalize everything, which is probably an exaggeration. But they also report that they attribute over $1 billion a year in revenue to personalization, which is very significant. So they're probably one of the most successful commercial users of personalization and reinforcement learning.
So Oljan, we have another question here.
Yeah.
Is reinforcement learning related to adversarial networks?
Not to my knowledge.
Okay. And I would encourage all of you to actually keep questions coming. We want to keep it live and engaging. So if you guys have any questions, feel free to use the chat window and type your questions. We'll try to answer all your questions within this. Otherwise, we can actually email afterwards. So yeah.
Okay, let's continue here. Script actually uses bandit algorithms that they describe for recommendations on its homepage, as well as in several other projects where they actually use our platform. And we can't disclose details of those other projects at this time since they're a customer. But I just wanted to mention that they are actively using these things in their product. And they're probably one of the most sophisticated users of these algorithms. And here are just some of the other companies that are using our horizontal platform for a variety of use cases, both on web and mobile, and as well as server side. And I won't go into details of these use cases. I will, however, report some of the results that some of these companies have achieved using our platform. Teespring, for example, which is an online platform for custom apparel, has been able to boost their revenue significantly. And Anydo, which is a major mobile app, has been able to also boost their subscription revenue. And Habits, or Simple Habit Tracker, is a smaller mobile app which has significantly improved its UX or reduced a form of UX friction.
So here we have another question from Anirudh. How mature is the science of using deep networks for reinforcement learning? So Ojin, would you like to just answer that question first?
Yeah, that's a good question. I was just doing research on that yesterday for this for these slides. I don't think there is any confirmed uses of deep RL in production, except for, I believe, Google's use of deep RL for neural architecture search in their AutoML products. So AutoML neural architecture search. Which is not personalization, which is why I did not get into that. The other use, I believe also by Google, is the data center power savings or cooling power savings project. So also by Google, I'll type that out. So also Google data center. And if you search for that, you should be able to find that definitely on the web. Again, I did not go into these because they're not personalization use cases per se. But as recently as just a few months ago, some people have looked for major applications aside from these of deep RL, and they failed to find any in production. Yes, I think that that includes deep contextual bandits. So, so if there exist any major production use cases, they simply have not been published. My guess is that it's quite likely that there are production applications of deep contextual bandits, especially, but I'm not aware of a published paper.
Right. And Arjun was talking about the Shopify personalization optimization. So I would let Arjun continue with the Shopify.
Yep, we will have time. I should have mentioned that in the agenda slide. We will have time at the end, definitely at least 15 minutes.
Yeah.
So, no worries. I will answer all the questions. So I did want to mention, I gave some examples of some of our customers using us, and I mentioned that we are a horizontal platform, and there are many use cases, of course. But one of the things that we're really excited about is, aside from providing a horizontal platform for the public to use, we're also probably the first provider of a fully verticalized kind of push button solution. This is an example of that. This is our Shopify app for personalized discounts. If you have a Shopify store, all you have to do is to add this app. So this little button you see here, you can see in the App Store for Shopify. And if you just add the app, and if you have any discounts configured, which you do, under discounts on the Shopify menu, so you may already have them configured, then you will immediately start personalizing and optimizing your discounts. So discounts might look like this banner above, and you can actually customize the look and feel as well. But the idea is that the personalized, the discounts, will not get presented to everyone. They will only get presented where it makes sense to improve your revenue. And being reminded that the app is not yet available. There's a beta version available that if you reach out to us, we can provide you a link with. We do expect the app to be available in a couple of weeks. So, so in the rest of the talk, I'd like to just talk about the benefits of this kind of approach to personalization and more generally optimization. As I mentioned, personalization is a form of optimization since we have to define a metric and the goal is to improve that metric. And so I'd like to contrast that to the other way that companies typically try to drive growth by running A/B tests or hypothesis tests. And some companies have built teams around this. I didn't get into growth as a discipline in this talk, but if you do some research, you can find out more about that. But in any case, the standard kind of state-of-the-art still way of doing growth in most companies is to have people, this could be actually one person, but typically multiple people, to design and implement variants of the product or service, and then to test these variants in production with data. I mean, by randomized testing, you are actually using data, live experimental data actually, to prove or disprove the hypothesis or to gather evidence for or against the hypothesis. And this process can take a while. Experiments can take a while to conclude, and they may succeed or they may fail. What happens is that, more often they will fail. Otherwise, you wouldn't run the experiments. And when they fail, though, what typically happens is that the ideas are typically thrown away because people think that the idea is not useful. It wasn't, how they imagined it, and they move on. They have to come up with new ideas. Now, on the other side, the new process that we propose, where personalization and optimization using reinforcement learning, as we just discussed, could be used, is to power this type of two-track process, what you might call a two-track process. So you still have experts designing and implementing variants on this outer cycle here, but you no longer have experts waiting for test results. The variants are being made available to this system that's always running. So we say that it's autonomous and continuously optimizing. And that system is designed to maximize metric gains or maximize growth. And in the meantime, experts focus on their ideas, They no longer need to, for example, define the segments to test on. They don't need to run the tests. They don't need to evaluate or validate the results, deploy the improvements, monitor for changes over time, and so on. So there's a lot of things that experts would have had to do somehow in the old process that they no longer have to do in the new process. So this should give experts much more time and energy to focus on their ideas. Not only that, but the ideas are utilized much better as we'll see in a moment. Let me expand a little bit further into this two-track process that I just described. So on the right side here, you see what the inner cycle in orange would look like. So you integrate our client libraries into your applications, your websites, your mobile apps, your server-side software, basically anywhere that you'd like to integrate. And as soon as you do that, our system starts collecting the session data that we described earlier. So we give an example of a checkout flow session. Sessions like that are collected. And as soon as session data starts coming in, the system starts learning or attempting to learn policies that look much like you see down here. So they're essentially mappings between different segments that could occur or exist and different variants that should be taken in those segments or different actions that should be taken in those segments. And on the left side, you see the outer cycle, which is where we have the experts getting their insights from the system and feedback from the system, and then actually upgrading their projects so that those projects can achieve even better metrics. So actually they would either implement new optimization projects or they would upgrade existing ones. And what upgrading looks like is that it can be a change of metrics sometimes, but more often it would be a change of variance in the project, especially removing variants that are not being used, or introducing new context that can be used by the system to define new kinds of segments in its policies. So this is the outer cycle. Now, as far as timing, the inner cycle, we strongly recommend should converge to its optimal metrics within at most 2 to 4 weeks. So this orange cycle we have on the right side, although it runs as fast as it can, its convergence to its improved metrics above the baseline should happen at most in at most 4 weeks. And on the left side, we recommend that cycle go roughly 4 to 6 weeks. Now, I do want to emphasize, it should be pretty obvious by now, that experts still play a critical role here. In fact, experts are driving the whole process. And this is one of the biggest misconceptions when you talk about AI or machine learning being used for these kind of use cases. People imagine a system that will simply keep improving your metrics autonomously, but that's actually impossible. We still need experts to design variants. We still need experts to learn from these projects to design even better variants and so on. And this is what our console looks like. It can help understand how our system works. Let me zoom into the session allocation section here. So we show you how your sessions are being utilized. Specifically, a percentage of your sessions, the 20% here, is used to measure a baseline to compare against. Another portion of your sessions are used for what we label learning. And this is, you can think of this as continuous A/B testing with automated segmentation. So this is where our system is experimenting and learning better policies that it then applies on the rest of your session. So the 64% is where the best known policy is being executed. And so this gives you a sense of how much the system is exploring versus exploiting are the phrases typically used in reinforcement learning. And then here you can see on the upper time series, you can see a typical progression of a project over the course of about 4 weeks. You can see that in the first week, if you look at the bar chart down here, it would be dominated by learning, but by the second week, it's actually mostly dominated by optimization. And definitely in the second, third, and fourth weeks, it would be mostly optimizing at that point. And you can see the system has mostly achieved convergence here by 2 to 4 weeks as we needed to. And then the other thing worth highlighting here is this section where we list each of your variants. For example, V4 here, we'll highlight V2, V3. And each of these variants is utilized in a certain percentage of sessions, such as V4 being used in 22% of your sessions. And you actually have multiple variants here that are creating value. So this is the contrast, the stark contrast between personalization, where you have multiple variants that are creating value and driving growth, versus A/B testing, where they can only be at most a single winner. So this is a pretty big difference that's worth thinking about. Now, let me dig a little bit deeper into this personalization and segmentation concept. So one contrast we like to draw between this type of system and A/B testing or hypothesis testing is that here the segments can be learned. So let's go back to that example with just two variants or one baseline and one variant. So to run an A/B test, testing variant against baseline, the first thing you have to do is you have to define or predefine the segment you're going to run it on. This could be everyone, right? All visitors to your website or all people who download your mobile app. Or it could be a subset. It could be only, I get a question. Let me get back to that in a minute. It could be only US users or English-speaking users or people on mobile devices or so on. So you could define your segment however you like. And if you could magically look into that predefined segment, it might look something like this, where you see it's about 60% dominated by people who prefer the baseline or who do better with the baseline given the metric that you've defined. But you still have that 40% in there that actually do better with your variant. However, because you're unlucky, the predefined segment was actually dominated by baseline, you get a negative result from the experiment. And again, you don't see the contents of the segment, you just see the result of the experiment. And given such a result, assuming it's significant statistically, you would likely just throw away that idea because you would feel that it's just not working. But instead of that, what we suggest is that you have a system that, given these two variants, is always looking for the best segment that it can find to apply those variants on. So it doesn't have to perfectly isolate the blue people, the people who do better with the blue variant. As long as it does a good enough job as it does here, you can get a positive impact instead of a negative impact with the same variant, right? So this is a pretty big deal, because an idea that you would have likely thrown away wasted all of that work and coming up with the idea, designing the variants, implementing the variants, and so on, wasting all of that work. Instead of that, you actually get a positive result. So you get an improvement to the metric you care about, and you get to learn about the segment. I mean, you get to actually get some insights that you probably didn't have before that you can then use in the next cycle. So really important benefits of being able to discover and learn segments this way. There's a question here. Don't you encounter the cold start problem with such self-optimizing systems? What is the initial policy and how is it determined? So that's actually easy to answer. It's a good question. So initial policy is always what we call random and identical to an A/B test. So the initial policy actually does not even depend on the context, and there's no segmentation to speak of. That's always a starting point, and as soon as there's sufficient data to start exploring in a segment or context sensitive way, we would start doing that. That's when you would start seeing policies that discern different segments. Great question. Okay, so let me now just give you guys some examples of learned segments, because I know it can get very abstract at this point. So here's an example from one of our customers who was using us to reduce cancellation or churn. So a customer of theirs clicks unsubscribe, and then they have an opportunity to try to convince them to stay. But the messaging that they use in that flow should actually depend on how they behave during their trial. So specifically, we found a segment where if they have not, a behavioral segment, where if they have not used their audiobook credits during the trial, then when they attempt to cancel, we should remind them of audiobooks. So there was a variant of the cancellation flow where audiobooks were prominent as a reminder, and that variant did significantly better on this segment because this segment likely included more people who just had not realized that they had audiobooks. So this is an important pattern. Another one from cross-promotion use cases that we typically find is that past behavior of whether you dismiss a certain kind of promotion recently, for example, in the last 24 hours, should really inform the strategy of promotion for that user. Certainly, you wouldn't want to show the same promotion again, but there might also be other promotions that are too close to that one that you wouldn't want to show. This is a very common one where device specs and the country would really impact things like personalized pricing or personalized offers, because obviously this would be correlated with income level and ability to spend, if not willingness. And then another common thing is that on small screen devices, on slow connections, people tend to be less patient. So user experiences that encourage people to skip steps, for example, go directly to checkout, or skip optional steps in a multi-step registration process or something like that, typically perform better than when people are on a large screen device on a fast connection. So those people are not as impatient. So this is kind of a general pattern. Now, the other benefit I wanted to talk about is what happens over time. So with a predefined segment, you could get lucky and get a positive result, right? So this segment, for example, is dominated by blue people. So you're going to get a positive result on that variant being better than baseline. But what happens if later on, inevitably, actually, the population proportion shifts and against your results? So here you have the blue population actually decreasing over time. Unless you're monitoring for this, you're not going to realize it, and this could really cause your improvements to erode over time. Whereas with learned segments, if they're continuously learned, you can actually depend on the system tracking these segments that your variants are applied on over time. So if the blue population is shrinking, then the variant will simply get applied less and less over time. And if it shrinks enough that the variant is no longer contributing enough to your metric, you can just drop the variant. So it's a very flexible, very intuitive way of managing variants in your production. Here are some concrete examples of this kind of thing. So here on the left side of this chart, in April, I believe, if you run an A/B test, this is a cancellation experiment. So lower is better here. If you run an A/B test, you would likely conclude that orange is best in April, with high significance. But in just the next month of May, actually orange is only the third or fourth best. So the test result that you had, even though it was statistically significant, was actually quite misleading because it came with the assumption that things won't change. But things always do change, as I mentioned, for reasons often beyond your control, such as just the acquisition channels like search engines or app stores just sending different people to your website or app, for example. And then the other thing is that tests can take too long to reach significance. Sometimes it's just because your data rate is low or your conversion levels are low. Either way, the uncertainty will be high and might take a very, very long time to eliminate. In this case, actually, this experiment with 18 actions, I don't know if you guys can see this, but with 18 variants, actually does not conclude in a 2-month period. So this experiment would be inconclusive, there would be no result, but in fact, our system in this case was able to generate about 10% additional revenue here, starting at about third week. So starting about here, we were able to use contextual policies. And you can actually see it down here. You can see it on the left side. The colors here, by the way, indicate which action is being utilized by our system in production. So if you just take a slice here, you can see, let me actually clean this up. If you just take a slice here, for example, you can see orange is used here and brown and a little bit of blue and purple. But here, for example, you have different actions. You have brown and yellow. And then by the time you get to here, you're mostly, in this region, you're mostly using purple and brown, aside from blue, which is baseline or control variant. So that one's actually not controlled by our system. Anyway, so this type of contextual application of variance was able to boost revenue by 10%, even in this kind of case where you're not going to get a conclusion from an A/B test. So just to summarize the benefits, the key benefits, finding best variance, of course, A/B testing and our platform will do just fine. And that's a great way to use data instead of hunch, right? But in terms of finding the best segments for your variance, A/B testing is limited, unfortunately, to predefined segments. So you're kind of rolling the dice on whether those predefined segments actually are the best segments for your variance. Almost always they won't be, or they won't be as good as they could be. But a system like ours can actually find the segments that are the best for your variance. And then in terms of sustaining improvements, it's very important to be able to track those segments over time as they change, as I mentioned earlier. Whereas with A/B testing, you're kind of rolling the dice on what happens over time. So even if you got a positive result, how do you know it's still positive 6 months later? And then here's a typical growth curve or cumulative gains curve, where we're comparing an optimization algorithm like a multi-arm bandit or contextual bandit in this case, I believe, versus an A/B testing procedure, which is designed to take a winner as a specific significance. I think 90 or 95% probability. It's a Bayesian A/B testing procedure. But in any case, if you compare these, you know that A/B testing is going to suffer because it's not designed to optimize. It's not an optimization procedure. It's a testing procedure, and it's designed to actually control for a certain kind of risk, statistical risk called the type 1 error or false positive rate. So the risk of deploying a change when there's no improvement. And of course, a procedure like that cannot compete with a procedure designed specifically to optimize, specifically to maximize gains. And this holds over a wide range of real-world use cases. So each of these is actually a real-world use case, actual A/B testing data. In other words, we cannot name these companies, but these are major companies in the Bay Area. So just wrapping up here, we have a fully baked example of our system applied to a mobile store that we, applied to a store that we developed from scratch as an example, both on mobile and web. So you can get all that on GitHub. And then our blog, I wanted to just mention, we actually have many more newer content recently, especially more technical content. And there's another blog post recently specifically on reinforcement learning for other enterprise use cases, especially those outside of personalization, of which there are quite a few. So that might be of interest also. Okay, great. Thanks, everyone. Let me answer the questions now, and then we'll be done. Let's see here. So the question is, I'd like to hear my views about reinforcement learning in quant finance and applications like stock option pricing, P2P landing, inverse reinforcement learning for stock trading modeling. You know, I'm not an expert, I have to say, in quant finance. And I did read briefly about that recently. And it was speculated in what I read that it's very likely applied in those domains. But typically, those who are successful with the use cases don't publish them. Because they don't want to, you know, share their secrets, right? So, so it's very hard for me to develop views around it. We've certainly not pursued those use cases, at least not yet. I do imagine that we would, but it tends to be, especially finance and healthcare, for example, are not areas that smaller companies like us or startups like us would pursue initially, especially if you have use cases in other verticals. I hope that, sorry, I didn't really answer the question, but did my best.
Great, yeah. Is there any other questions from the participants? And Anirudh, keep those questions coming, and we are trying to find those answers for you. As Aljan mentioned, we don't have the use cases specifically designed in quant finance areas, but we'll definitely keep an eye, and whatever we can find, we'll definitely share with you. So here's another question from Amit. Aljan, if I'm building a Pandora type application for music, how can am.ai platform be useful for me?
So that's a good question. Well, there's a lot that goes into building a Pandora type application. So one of the major things, I guess, is a recommender for, you know, the next song, basically. And for that, we probably couldn't replace the core algorithm that you would use. However, what we would do is allow you to easily deploy multiple algorithms and dynamically show you, dynamically take advantage of those multiple algorithms on different segments and show you how different segments react to the different algorithms. So what you can do with that is basically use our platform to improve your metrics much faster than you could, for example, by A/B testing that algorithm. Or it could be any other thing that you would want to A/B test, such as your UI or the user experience. There's a lot of things aside from choosing the next song or whatever, such as you know, how do you present the songs? How do you present the controls and things like that? And you might have ads, you know, if you're making money out of that, or some other monetization that you would want to optimize probably. Actually, I should have mentioned perhaps, but monetization, for example, personalized offers and personalized pricing are one of the most successful use cases that we've seen for this type of platform. So we can definitely help you monetize that app for sure.
And I think Aljan had a similar slide on Netflix on how Netflix actually uses recommendation. So that is something I think it is quite possible with reinforcement learning. So Amit, let's keep the discussion going, and let's, yeah, I think he has one more question. Okay, I'll hold on. Okay. Is there any other question from any other participant while Amit is working on his question?
Definitely our blog, which every day we get more technical articles in there, and I think we'll continue to do that. I think that's the right URL. So try that. Under the hood, I think you're probably referring more to the machine learning parts of it. Those parts we haven't written much about on the blog. We've started sharing more. I didn't actually talk about it in this talk because I wanted this to be pretty high level, but I think we will write about that in the blog. So I'm sure if you follow our blog or Twitter feed, you will hear more about that in the coming weeks and months. So, Amit, so you're saying if you do a second experiment, there's no ambiguity because you've concluded the first one, I guess. And now the second one, you focus on new things. Now there's two questions. Let me answer Amit's question first. So Amit, so you could always do the exact same thing with our platform. So you could run a cycle, and at the end of the cycle, actually just take one of the variants and drop the rest. So you can do that. That would be kind of like using it as almost like multi-arm bandits, except you did get some contextual bandits during the optimization. And then you can hard code that single variant and then move on to your second project or second cycle where you have a new set of variants against the other variant. So you might avoid ambiguity that way. Now, as far as what we would recommend instead of that is that you focus on the metric and focus on iterating not kind of one variant, one best variant at a time, but with a subset of variants. So from the first cycle, you'll probably get not a single winner, but you'll get multiple ones, and you can make the call of whether they're worth keeping in terms of metric improvement. But don't worry about having a clear, unambiguous winner. Just accept that you have multiple variants that are performing better on different segments, and then it's okay to introduce other variants and then see what happens. So it could be that the new variants you add take over from the other variants in some segments, but not in other segments. It's very hard to predict, but there won't be an ambiguity, so to speak, so much about, first of all, the overall results. I mean, we're always actually looking at the statistical significance of whether our optimization is doing better than baseline, but also there shouldn't be much of an ambiguity on which variants are delivering value on which segments. So those types of things, there's no ambiguity on. I do agree with you that it's not as unambiguous as running a specific test for a specific decision you want to make. But again, that's under the assumption that things don't change, right? So that very unambiguous result you had from the first experiment, is that still valid even by the time you run your second experiment, right? You make a big assumption there. Okay. I hope that helps, Amit. So let me know otherwise. So Anirudh asks, do you have use cases of high performance computing? Do you use any framework in particular? I couldn't say actually. I think we've used in the past, but I'm not sure that we still use them.
Thank you so much, everyone.
Thanks, everyone. Bye.
Bye.